If you've ever scrolled through photos beamed back by NASA's Mars rovers, you might have noticed something strange. Dried up river channels, ancient lake beds, and clay minerals that only form when liquid water is around. Mars looks like it used to be a genuinely wet, mild kind of place. It's not that scientists always assumed Mars was born of frozen, airless rock. In fact, the closer researchers look at the ancient rock record, the more Earth-like this planet's early days appear. Instead, something else, something a lot more magnetic, happened here. Planets need a magnetic field. It's their shield against the sun. Without one, the solar wind, a nonstop stream of charged particles blasting off the sun's surface at about 1,000,000 miles an hour, can slam straight into a planet's upper atmosphere, knock gas molecules loose, and carry them off into space, all of which can leave a planet's air dangerously thin. Mars used to have that shield. Billions of years ago, a molten, churning core generated a global magnetic field strong enough to deflect most of the solar wind. But Mars is smaller than Earth, so its interior cooled fast. The core's churning slowed. Its magnetic field faded out somewhere between 3.7 and 4.2 billion years ago, and the atmosphere was left completely exposed. The result? A planet that went from thick, warm, and maybe even livable to the cold, bone-dry, barely there atmosphere we see today. For Mars, that was a slow-motion catastrophe billions of years in the making. But for scientists hunting for habitable worlds, it's turning into one of the most useful test cases in the galaxy. One mission found the atmosphere is still leaking away today. NASA's MAVEN orbiter clocked the solar wind stripping off about 100 grams of gas every second, a rate that jumps roughly tenfold during a solar storm. Rover missions found the receipts on the ground: dried up river channels, lake bed sediments, and minerals that only form in liquid water, proof Mars once had air thick enough to keep water flowing across its surface. And chemistry sealed the case. The ratio of heavy hydrogen to regular hydrogen in today's Martian air is roughly 6 times higher than Earth's, a fingerprint left behind because light hydrogen escapes to space more easily than its heavier twin, pointing to Mars having lost at least 80% of its original water. But figuring out Mars's mystery wasn't just a history project, because the same measurements that show how the solar wind stripped Mars's air also map out the radiation environment future human astronauts would have to survive on the surface. In other words, this research is also helping engineers plan how to keep the first Mars explorers alive. And remember those solar storms that spike Mars's atmospheric loss? Watching exactly how they slam into a planet with zero magnetic shield is also helping scientists model space weather closer to home, since those same bursts of solar particles can knock out satellites and power grids here on Earth. So watching the sun strip Mars bare helps protect future astronauts on Mars and helps protect our tech back on Earth. Sounds like a real win-win situation. Of course, it isn't quite that simple. The missing magnetic field isn't the whole story. Mars is all just small, with weak gravity, so some of its lighter gases likely drifted off into space on their own, magnetic field or not. Timing matters too. The young sun blasted out a far fiercer solar wind billions of years ago, so Mars probably lost the bulk of its atmosphere fast and early, and untangling exactly how much happened when takes serious detective work. And confirming any of this takes expensive, patient science. MAVEN spent more than 11 years gathering data before it fell silent in December 2025, and its planned successor, a twin spacecraft mission called ESCAPADE, is still years from actually reaching Mars. It's currently looping around a gravitational parking spot near Earth, waiting for the right planetary alignment to make the trip in 2027. But researchers have started using Mars as a real-world benchmark, and because a planet without a magnetic shield is unlikely to hold on to a breathable atmosphere for long, checking a distant planet's size, mass, and distance from its star, all clues to whether it could sustain a magnetic field of its own, has become one of the most useful filters for deciding which of the thousands of known exoplanets are actually worth pointing an expensive telescope at. So even though directly confirming a magnetic field around a planet outside our solar system is still brand new science, so far, researchers have only picked up a small handful of tentative hints, like strange radio bursts from a red dwarf star called YZ Ceti that might be triggered by a magnetic field around one of its planets. The story written into Mars's thin, red air might eventually help us spot which distant worlds are actually a breath of fresh air.